All right, so today we're going to take a look at the last section of conics, which is the hyperbola. And a hyperbola has two model forms of all of the conics we talked about thus far have been continuous graphs. And if you think back to algebra, a continuous graph is a graph such that when you put your pencil on the paper, you can trace the entire graph without removing the pencil from your paper. So here's just a couple of examples. For example, this parabola, it's continuous because I can put my pencil on the graph and trace the entire graph without removing the pencil from the paper. However, we look at this second graph, and this is actually the graph of a hyperbola. Okay, this is what's considered to be a discontinuous graph, which means in order to trace the graph, you can start tracing the graph. And then it comes to a point where you have to remove your pencil from the paper and put it back on. Now, even though it appears that there's two equations making this curve, it's actually one equation. All right, and that equation is called a hyperbola. And we're going to look at the two model forms. Now, fortunately, in this last section, we don't necessarily deal with hyperbolas that are not centered at the origin. Okay. We talked about the ellipse in the last class, and as far as the ellipse is concerned, an ellipse has a major axis, and the vertices and the foci are located along that major axis. And then we have a minor axis. However, for hyperbolas, we don't have a major axis or a minor axis. We have what's called a transverse axis. And on that transverse axis, you can find the vertices and the foci. So the first model form we're going to take a look at is a hyperbola with a horizontal transverse axis. All right, so here's the x and y axis. And for a hyperbola with a transverse axis, with a horizontal transverse axis, our graph looks like this. It kind of opens up to the left and to the right. Now, since this has a horizontal transverse axis, the vertices, so I'm going to call that V1 or V and V prime. The vertices and the foci are located along this transverse axis. If you have a hyperbola with a transverse axis that opens up to the left or to the right, here's the model form. It's x squared over a squared minus y squared over b squared is equal to 1. Now, in a hyperbola, there is no condition such that a has to be greater than b. The condition here is whichever variable comes first, that determines your transverse axis. So for example, since this x squared is our first term, this is going to have a horizontal transverse axis. The coordinates for the vertices are going to be plus or minus a comma 0. The formula for the foci is plus or minus c comma 0. And again, these are for conics that are at the origin. C, now this formula for C different it differs from the C formula for the ellipse. C is going to equal to the square root of a squared plus b squared. So for the ellipse, it was a squared minus b squared. But for the hyperbola, it is the square root of a squared plus b squared. So this is basically the model form. All right, so just as in the ellipse, we're given a squared, we can take the square root of a to get a. B squared is take the square root, we can get b, although b is not needed in order to plot for our purposes. And then we have c, which is equal to the square root of a squared plus b squared. All right, the next model form is a hyperbola with a vertical transverse axis. So our graph will open up and it's going to open down. So here again, we have a vertical transverse axis. So the vertices and the foci are located along that axis. Okay, dealing with this model form, we have y squared over a squared minus x squared over b squared equal to 1. All right, so here again, there is no stipulation that a has to be greater than b or b being greater than a. The only stipulation is if you see a minus in between these two terms, the variable that comes first determines your axis. All right, so let's pull out the coordinates for the vertices. So the vertices here are going to be 0, comma, plus or minus a. The formula for the foci are 0 plus or minus c. And c is going to equal to the square root of a squared plus b squared. All right, so here are the two model forms. Okay, we're first going to start by graphing. And I'm just going to go to XYZ homework to graph. Okay, nothing to really graph by hand. But there's a certain pattern that you got to follow if you're graphing these things by on the computer. All right, so now that we have the two model forms, let's go into the conic section. I believe the first, 4 problems? 1, 2. Yeah, the first 3 problems. All right, so we're going to take a look at problem number 1. All right, so it says graph the equation y squared over 9 minus x squared over 16 is equal to 1. Well, first thing I notice is that it is a hyperbola because of the minus. My y squared variable comes first. So if we look back at our model forms, if the y variable comes first, this is a hyperbola with a vertical transverse axis. So I'm going to look for the graphing tool that opens up or down. All right, so I'm going to choose the second one. I'm going to blow that up. All right, so notice we have the parabola, the circle, the ellipse, and then we have the hyperbola. Since our y variable comes first, this is going to be a hyperbola with a vertical transverse axis. Right? So I'm going to choose the next to the last model form. Okay. Now here's the way to plot it. since it's situated at the origin, okay, and the reason why I know this thing is situated at the origin, because let's say if I look at the next problem, notice I have constants attached to my x and y variable, right? And why is this thing starting at question number 2? All right, but notice I don't have any variables attached. The y variable comes first, so I'm choosing the model form for a vertical transverse axis. The first thing I'm going to do is plot the center, right? So I'm going to plot it exactly in the center. Next, I'm going to move along my transverse axis. So I have a vertical transverse axis. So from the center, I'm going to go up a units. So notice in my model equation, I'm given 9 as my denominator. The square root of 9 is 3. So from the center, I'm going to travel up 3 places along the transverse axis. If I look underneath the x variable, I have 16. The square root of 16 is 4. So I'm going to move 4 places to the right. 4. I'm going to lock that in. And that should be our graph. All right. So you want to plot your center, move along the transverse axis, and then move along that non-transverse axis. All right. So for whatever reason, I'm starting at problem number 2 instead of problem number 1. All right, so now I've refreshed, it's giving me a problem number 1. So let's take a look at number 1. And it says x squared divided by 9 minus y squared over 4 is equal to 1. So notice that this is a hyperbola because there's a minus between my two terms. The x variable comes first, so this would be a hyperbola with a horizontal axis. So I'm going to choose that last model form, and I'm going to plot the very center. Right. Since I have a horizontal transverse axis, I'm going to move along that axis. The denominator for x squared is 9. The square root of 9 is 3. So I'm going to move 3 places to the right. Underneath the y variable, b squared is 4. So the square root of 4 is 2. Therefore, I'm going to go up 2. And I'm going to lock that point in. Okay, and I'm going to submit, and this should be our graph. So you plot the center. Well, first you choose the model form, plot the center, move along the transverse axis, move along the non-transverse axis, set your point, and then you have your graph. Now, for those first two, they were centered at the origin. However, problem number 3, okay, this is the only one in this section that's not centered at the origin. But nonetheless, we're going to find this model form. And looking at this particular problem, the x variable comes first. So the model form is for a hyperbola with a horizontal transverse axis. Okay, so I'm going to choose that last model form. Next, I want to plot my center. So remember that h follows x, k follows y, and you must reverse the sign. So the center for my problem is actually going to be positive 1. So I'm going to go over 1 place to the right, and I'm going to go up 2 and plot my center. Next, I'm going to move along the transverse axis. A squared is 4, so that means that A is 2. I'm going to go 2 places to the right. B squared is 9. That means B is equal to 3. So I'm going to go up 3 units. I set in my second point, and we have our graph. All right, so just like in the ellipse we had to move along the major axis first and then the minor axis. Here we move along the transverse axis and then the non-transverse axis. All right, now the last two problems, we're given an equation. They're both centered at the origin, and we're asked to find the vertices and the foci. Okay, so for problem number 4, it says write the equation of the hyperbola in standard form. Identify the vertices and the foci. Right. X squared over 25 minus y squared over 4 is equal to 1. We're asked to write this in standard form. So I'm simply going to square those denominators. So we have x squared over 5 squared minus y squared over 2 squared is equal to 1. Okay. That's pretty much what they want for standard form. Next, we're asked to find the vertices and the foci. So in order to find the vertices, if we look back at our model form for a horizontal transverse axis, right, the vertices are located at plus or minus a comma 0, and the foci are plus or minus c comma 0. Right, so the vertices plus or minus a comma 0. So a is going to be 5, right? So our vertices are located at plus or minus 5 comma 0. And then to find the foci points, okay, from our model form is plus or minus c comma 0. So in order to find c, we use that formula. C is equal to the square root of a squared plus b squared. A squared is 25. B squared is 4. And if I add those two together, I get the square root of 29. Right. So the foci are located at plus or minus square root of 29 comma 0. So we have negative square root of 29 comma 0 and positive square root of 29 comma 0. So the formulas are not too involved as the other formulas, okay? Because we're not dealing with anything that strays from the origin. And then for our last problem, same thing, write it in standard form. So we're simply going to square out the denominators. So that's y squared over 3 squared minus x squared over 2 squared equal to 1. If you look at your model form, the vertices are located at 0 plus or minus a. Okay, and we can pull a from our standard form. A is going to be 3. So those vertices are located at 0 comma plus or minus 3. In order to find the foci, our model form says that the foci points are 0 comma plus or minus c. So if we find c by using that formula, that's the square root of a squared plus b squared. A squared is 9. B squared is 4. So C is equal to the square root of 13. So our foci are located at 0, comma, plus or minus square root of 13. Okay. And we have the vertices and the foci.